when he left, are there issues? Are there any issues?
Did you succeed doing the full practical session?
I think to some extent. Maybe.
Yes, we didn't go. Well, we completed. We completed
Okay. Thanks.
the lab.
Mhm.
Uh, there was a question about modules and where to put modules, but we found it out.
Okay.
Uh,
So that's pretty cool. Okay, so it was clear. You understood now. You understand now how it works.
yes.
Okay, cool. So Ansible is really a tool that is used widely used over the world. Okay, it's a very famous tool. So I think it worth investing in Ansible to learn it. Even for non-HPC deployment, I mean, if you need to maintain an IT infrastructure uh, for university, for enterprise, whatever, not HPC, Ansible is also a good way to go. Okay, thanks a lot for this feedback. Okay, so let's continue today. So this is the last day. It may be a bit, uh, well, a lot of things to see today, but I want to provide you all the detail, and after that you will have time to investigate yourself and to explore everything. Okay. So today we are going to see how to set up an HPC cluster automatically. So I'm going to present you, well, over the world, there are multiple projects to provide an HPC stack. Okay, what we call a stack is a software that allows you to deploy an HPC cluster. You can find OpenHPC, which is, I think, the famous one. But you have also very nice stack like Werewolf. Werewolf is also very well known over the world. So there are multiple stacks available. Today I'm going to present you one called Blue Bankies. It's a new one, okay? We created it like 2 years ago, and it is currently used in Europe to deploy the HPC clusters. All the Euro HPC cluster are now deployed with this. So it's still new, okay, but at least it works. And it's an open source project, so it's hosted on GitHub. So it's a new generation stack based on Ansible, so not relying on many scripts, but relying on another tool, Ansible. It's pretty secure, it's scalable and very light, okay? It is also part of a project here we called Algoric. So it's not a project related to an enterprise or to government. It's, I would say, a completely autonomous project from users who wish to promote green and open source high performance computing. So we have a website, for example, here that describe what we are trying to do. Currently, the only version we have is in French because we are hosted in France. But basically, what we do is we get. It may sound incredible, but in Europe, a lot of HPC centers, big ones, change the cluster every 3, 4, 5 years. Okay, so after 3 years or 4 years of usage of the cluster, they just change it. Okay, they get a new one. So the idea of Algoric is to say, well, these clusters are not dead, they can still be used. I mean, if you have followed what happened recently on the CPU market, you may have seen that, for example, if we take the Intel CPU, if you take a CPU like 10 years old, it is still pretty efficient, still pretty powerful, okay? Because right now the difference in power is not very impressive each year. So the concept of Algoric is to say, well, we can reuse all of this HPC cluster, well, we just provide it as best effort. We say to our users, we get a cluster, and I think you can do the same. It's a smart move. If you don't have the money to have a brand new cluster, you can contact big HPC centers and ask, do you want to dispose of one of your cluster? Maybe you want to dispose of one of your current cluster, and you want to have some kind of communication. I mean, we can say, hey, look, we took your cluster, so it's green, it's cool, blah, blah, blah. So they like communication. On the other side, you have a new cluster. And this is what we do here in Algoric. We get old cluster, not that old, in fact. We bring them a new life using a best effort approach. We say, we don't have the way to, I would say, to provide components. Okay, if we have a failure somewhere, we don't have a way to grab new component, but we don't care. It's a best effort cluster. So we take half of the equipment in production and we keep half of the other part for spare part. Okay, and that's all. And then we have a free cluster, and that's what we do today. So we have a small team dedicated to that, and the idea is to bring a new life to old HPC cluster. So this is the Algoric project. And to ensure this project, to make it work, we needed an open source stack to deploy the clusters. Okay, so that's basically the idea here. So we created the BlueBanky stack, and because we always face very well, we have to deal with proprietary clusters, Dell, HP, Buell, Cray, whatever. We need a stack that is generic enough to adapt to anything. So that's what BlueBanky is aimed for. Currently, BlueBanky is only for Red Hat CentOS. And in the next version, we are going to bring support for Ubuntu also, because we need more and more users are asking for Ubuntu. So we will provide support also for Ubuntu. So that's what is this project, okay? And that's why I wanted to present you today this project. You can use another stack, okay? Of course, it's just one of the possibilities, okay? So we have GitHub. Everything is available on GitHub. All the source code, okay? It's quite light. You can find anything on GitHub, okay? So we tried to create something as standard as possible so that system administrator can find urgent help on the web. We don't do specific development. Everything is generic. If you follow the documentation from Red Hat, for example, it matches like perfectly what we do. So the idea is to provide something very simple with no reference database, so it's only text file based. Okay, it allows easy editing for new users, and we rely only on SSH because we are using Ansible. And as I said, the idea is to have something compatible with as much hardware as possible. We can deploy on HPC cluster, we can deploy on laptop, it can deploy on workstation, it can even deploy on Raspberry Pi. We tried and it works, okay? Because, well, we needed something that can be deployed easily and fastly, okay? Because we have a lot of things to do, and I don't want to spend a lot of time deploying things. So why did we use Ansible? As I said previously, Ansible, SaltStack, and this one are new generation tool, and they are Python based, okay, based on YAML, JSON, Jinja 2, and they have the ability to loop over the data. So we have seen yesterday that you can create a loop inside your templates. So basically, you can have very simple templates that create a very, very expensive, very big file at the end. So that's quite interesting. Ansible has a very active community. You can ask questions on the community. There are a Google forum. You have the GitHub of Ansible, many space where even on Stack Overflow, you can ask questions many people know Ansible, so you can have a lot of answer quickly. So the idea is to migrate to all pets to pets on cattle philosophy, meaning that now you don't care about your compute node. It's okay if you lose one. It's cattle. Okay, it's like you have thousands of cattle, and you just if you lose one, it's okay. You just deploy again, and you don't care. You don't try to investigate what's going on if it's not redundant. So you have your management node. So what you should take care of, and then your compute node. It's a cattle. You don't really care. Okay, you lose one, that's okay. So that's the philosophy. So Blue Monkeys is based on Ansible. Blue Monkeys is just a collection of roles. Okay, remember you have seen yesterday what a role is in Ansible. Blue Monkeys is just a bunch of roles. That's all, nothing else. So it's based on Ansible, which is a tool from Red Hat. So if I show you, for example, the GitHub, the Git page of Blue Monkeys, in fact, everything are here, the roles. We have a lot of roles available to deploy an HPC cluster. And here you have the core of the BlueStack, which is just how to deploy a bare metal system. And then in the community part, here you have additional roles that I would say specialize your cluster. For example, you have Grafana to have some display, OFED for the InfiniBand, OpenLDAP, PowerMan, Prometheus for the monitoring, Singularity for containers. You have the Slurm, many things available to specialize the cluster. Again, it is young, so we are like 5, 6 working on it, but we are increasing, and it's quite cool. So since you're still fresh now, let's speak about support. So if you need to have some help regarding Ansible, you have, of course, the documentation online. You have Red Hat if you need professional support. Okay, in case you do very complex things, maybe you need Red Hat support. You have the Ansible Galaxy, which is a space where you can find a lot of users' roles. Okay, there is some kind of community sharing roles, so you can browse the Galaxy and say, "Oh, I want a DHCP server." You go on the Galaxy in the search for DHCP server, and you're pretty sure someone already did it. Okay, and you have a very interesting page, the Jinja 2 template designer. It's a very big page that contains all you need to know about Jinja 2. I use this page like 10 times per week. It's very dense, a lot of things, but very interesting. Okay. Don't worry, I will send again the slide to you this evening. And regarding Blue Monkeys, the main website is bluemonkeys.com, and the GitHub is GitHub Blue Monkeys. So pretty generic, nothing weird here. Okay, so let's speak about the bootstrapping. So right now, Blue Monkeys rely on RHEL 8 or CentOS or Rocky Linux or whatever. So as I said, we want to bring Ubuntu support in the next version, but currently it's only CentOS. So you need to grab your repositories. So CentOS, Ansible, the core of Blue Monkeys, community if you want to use Blue Monkeys part, and extra is your own if you want to add more RPM or more small packages. So the concept is first you grab your repositories, then you will install your management node as we did. Okay. So you will install the minimal operating system. Remember, always install the minimum operating system. It reduces the attack surface for security. Okay, always install the absolute minimum. If you can avoid, don't install a GUI, don't install GNOME, don't install KDE, whatever. Keep it simple. Okay, so then we start with
Hello.
bringing up the main network interface. It's what we did. You upload your
Bernard.
repository, you create the repository manually, then you install Ansible. So that is, I would say, the manual part. You need to do it manually. It's always like that.
Bernard.
It cannot be optimized. Yes?
Yeah, please. I just want to raise this question. The very first day you talk about CentOS being going out of support, or very soon it is even dead already. and we'll be going to use Ubuntu very soon.
Yeah.
And we know Ubuntu, when you are installing Ubuntu, is there anything like minimal installation in Ubuntu? That means it's going to be like a full package of Ubuntu you'll be installing in that case.
In that case, well, once we have the support of Ubuntu, it's still not here, but it will be exactly the same. You will just need Ubuntu. Ubuntu already bring Ansible, so you don't need to grab any additional repositories. Okay, and you will just need to add the repository for Blue Bankies, and then on Ubuntu it will be working directly. If that answer your question.
Okay.
But support for Ubuntu is only scheduled for end of June, something like this, not before that. I mean, on this project, but maybe you can use another way or you can do it yourself. It's okay. It's just a way to deploy things, okay?
Okay.
But yeah, on my side, I also need Ubuntu for my own cluster. So then the idea is you will tune the Ansible inventory. Okay, so like what we did yesterday, but this time there is some kind of way to do it because this is a unified stack. So you need to comply with the data structure. And then you're going to deploy the whole management configuration in one step using Ansible. Okay, so you don't have to redo all what we did the first day. So build things, create file manually, etc. Everything will be generated in one step. So that's basically the idea of a stack. It will do it for you. It's automatic. Then your management node is ready. So you're going to deploy then using PXE. Remember, we did that the first day with IPXE ROMs. You're going to deploy your cluster. So again, the stack brings everything you need. It brings the IPXE ROM. It's already built in a package. You have some tools to manipulate how node should boot, etc., etc. So everything is provided. So you will deploy all the node, and then using Ansible, you're going to update and push configuration everywhere on the fly. And the idea is you should be able, as a system administrator, to deploy and redeploy again the same configuration all the time. It's idempotent, so this is a hard task because when you develop a stack like this, you need to create fully idempotent things. Means you should be able as a user to reapply it without breaking anything. Okay, so that's basically one of the main concepts of the stack. So, okay, so let me show you exactly how I can bootstrap my management node. Okay, so I just download the Blue Bankies repository. Okay, so I'm going to create the folder and I'm going to extract. I need to move it. Be sure it's here. Yeah, so right now I have my, I just created an STL. Okay, so right now I have my repositories ready, okay? And then as described in the Blue Bankies documentation, where is it? Blah, blah, blah. Just need to remember where I put it. Blah, 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 CentOS, Blue Bankies. So I just need to create this repository myself. So of course, I'm not using CentOS 7 anymore. Check access my repository. So I will do update it right now. Okay. So basically, now I have access to my Bluebankies repositories. Okay, so I have now I can install it now. So DNF. I need to So to follow the documentation. So what you need to do now is to grab the stack itself. So you need to install few tools. Okay, you need to install Git or everything to be able to grab the stack itself. Then I'm going to clone the stack directly inside the etc Bluebankies folder. So the reason why we didn't put the stack in etc Ansible is because maybe as a user, you want to be able to have both tools side by side. You want to still use Ansible for your own purpose, and you want to use the Ansible, the Bluebankies part for something else. So doing that, you can share both tools because Bluebankies still rely on Ansible. So just the only things you need to do is you need to specify to Ansible when you want to use Bluebankies, look, now my configuration is here. It's this one. Okay, so if you do that, then now Ansible knows that he needs to use Bluebankies instead of Ansible. We just change the main folder, in fact. So now if I go in etc Bluebankies, here you have everything available. So all the roles we said are here available. Okay, everything is here. And I'm going to use one of the example provided. So I'm cp-a resources example. I'm going to use the inventory of the simple cluster and put it here. So right now I have an inventory. So if I do an Ansible inventory minus graph, so this is basically what was provided as an example. Okay, so I have my management node called management1. I have my compute node, C01, 02, etc. So we are going to adapt this to match the cluster we did the first day, remember, with Odin, Heimdall, Valkyrie, etc., etc. We are going to adapt the inventory to match this, okay? But basically, the inventory, the example is provided as is, okay? So now let's see how it is made. So just few words before we proceed about Podman. The stack is able to run in containers. Even the stack itself, the management node, you can put it inside a container. So you can test it inside a Podman container. What is interesting with that is, for example, right now, if you want to test it from an Ubuntu, you can just pull a Podman for CentOS or Red Hat, and it will work on your Ubuntu doing that. Or basically, if you want to update to the next version of the stack, but you are in production, you don't want to break anything, you can start a Podman, a container. Okay, Podman is an alternative to Docker. It's, I would say, the new Docker. You can start a Podman, deploy the new version of the stack in the Podman, and test it. You will keep your system untouched. Okay, so that's a way to upgrade, for example. So Podman is really a nice tool. If you know Docker to use containers, Podman is a new way to use containers. I would say it's a new Docker. So how do you configure the stack? Okay. Well, so this part is not very interesting. We just focused a lot recently. Well, you have to know that the Jinja template can be very slow. So if you have a very big cluster and your template are not very well developed, they will be very slow. So we focused a lot on performances in the latest release. So as I said, Bluebankies rely on Ansible, especially on groups and variable precedence mechanism. Okay, the two main features of Ansible. So the stack is flexible. You will see that by default, you have only few parameters available, but many features are hidden. You need to check the documentation. You can do many advanced things, in fact, with it, because the stack is made to deploy very big HPC cluster. As I said, in Europe, many clusters are not deployed with this stack. And well, there are many features hidden, in fact, inside the stack itself. So you can use multiple Linux versions at the same time. So right now, Red Hat, CentOS 8 or 7. And soon, as I said, Ubuntu, other things. And also the stack handle Intel x86 64 architecture, but also in the next version, we bring support for ARM64, okay? So Raspberry Pi or whatever. So the structure is slightly different than the default Ansible one. Sorry, just a few seconds, need to answer, okay. So the main folder is etc Bluebankies, as I said. The inventories with an S this time is in Bluebankies inventories, and the group vars all, as we said, contains all general variable. The group vars all equipment contains equipment default variable. You will see that we create a group per equipment. It allows us to specify kernel parameters, IPXE specific ROM, because you will see that there are multiple ways to do IPXE, and sometimes some nasty equipment need a very specific ROM. So we support them in Bluebankies. So many things are for equipment, but by default, there is an all equipment that I would say it's the default that bring variable for all the equipment. And then you need to use precedence mechanism to say, no, for this specific equipment, I want something else, okay? So equipment X, group var equipment X for other equipment than the generic one. In the inventory cluster nodes, you will put your nodes, your equipment in the groups, cluster groups, you're going to put your groups, everything rotate to groups. The playbook are in etc Bluebankies playbook, and the etc Bluebankies roles contain the roles. And if you want, well, this is for you, if you want to add more roles, you can put a custom one in roles custom. So it allows you to bring more roles if you want. So how it is made for a node, for example, to describe a node, we use the YAML format. Okay, it's not the ini one, but the YAML format. And if you remember what you have seen yesterday, the first one you see here is a group. We call it the master group, so it's always prefixed with mg underscore. Okay, the prefixing is important. In the code, it allows us to detect what is a master group and what is not. Okay. So we call it mg master group and the name. For example, here it's management. Then we created a subgroup equipment underscore. So it defined what hardware it is. So is it a Supermicron hardware, which motherboard, etc. Maybe it's a Dell equipment. So again, I create a specific profile for each equipment. And then I describe my host. Okay, so name of my host. For each host, so this way. For each host, you can see we define network. So basically, the network interfaces are listed just above the variable network interface. It's a list. You can see it's a list, okay, because you have dash. What is important to understand is that on very sophisticated cluster, you have often a lot of network interfaces. For VLAN, one for the BMC, one for maybe a DMZ, for production, whatever. So you need to handle a lot of network interfaces. So you just list them here. What you need to know is that the list order is important. In YAML and in Jinja, the list order is preserved. Okay, so when you iterate over network interfaces, the first item will be this one. The second item will be this one, etc., etc. So we used that to say the user can now define what should be the main interface of an host. So basically, the first interface you define here is the one used by the stack to identify the host. So if I ping, for example, here, if I ping management 1, it will ping on this IP 10.10.0.1 because this is the first one listed here, not on the interconnect, for example. But sometimes maybe you need system to be directly resolved on the interconnect. It happened. So then you switch, okay, you put the first one, etc., etc. On the first management network, because if you want to be able to deploy the operating system, you need also to be able to SSH on it. The first item, well, it's more sophisticated, but basically the first item in the list that is a management network, you will see that later, is used for SSH, okay? Because sometimes you want to be able to ping on a very specific IP, but you want SSH to go through another one, okay? A good example is if you want your node to ping on the InfiniBand network, on the interconnect, you cannot say I want also to SSH over the interconnect because interconnect need specific packages. So the first time you deploy your operating system, you will not be able to use the interconnect to SSH on it. So you're blocked. So the idea is to say I want to use an Ethernet to SSH on my node, but I want then to ping over the InfiniBand. It's up to you. Okay, so as I said here, for example, in the first example, if I ping the host, I will be on 10.10.0.1, and if I SSH here, I will be also on 10.10.0.1. If I revert, if I put the interconnect first, if I ping the host, I will ping on the interconnect, but again, if I SSH, since interconnect is not a management network, you will see how to describe which one is management or not later, then the SSH will go through Ethernet, okay? Basically, it's a way to secure your SSH access. So in Bluemonkey's networks are defined in the file groupvars, all general setting network. Okay, so it's again, there is a sample provided in the example. Each administration network is prefixed by a fixed pattern. By default is ICE X Y. X is a number, Y is a number. Okay, so it's a fixed string. X is the number of the current iceberg. An iceberg, well, you don't really need to know what is an iceberg right now, but basically the stack is able to manage multiple clusters at the same time. Because some users, some very big data centers, have clusters so big that they need to split it in multiple parts. And the stack allows that. It allows to manage very big cluster. But in normal time, you don't need that. So you just use one to replace the X. And the Y is whatever you want. You can name it what you want. So it can be called ICE1 dash production, and it's okay. You just need to be sure that you use ICE1, okay? Because you are not going, I think, to use multiple iceberg right now. It's a very advanced feature. And then services IP are set for each administration network. We will see that later. So you can name it with the standard pattern. Okay, don't use very specific characters. Okay. Then regarding equipment profile, some groups, okay, in the stack are very important. As I said, you can prefix groups with MG for master group, and you have to prefix equipment related groups with equipment underscore. And for each equipment, you are going to define specific hardware parameter. Is it a BIOS, a PC BIOS, so legacy BIOS? Is it a UEFI boot? Do I need to specify a specific kernel parameter, specific console? Do I want to set up the firewall? Yes, no. How I want to partition the system? Maybe I want to do some specific partitioning. What operating system I want to use, because you can mix them. As I said, later we are going to bring support for many things. Equipment type, which keyboard, users. This is for the BMC. What are the users, etc., etc. So you are going to specify a lot of specific parameters. So this is an equipment profile. You define specific variable for each equipment. Okay. So OS distribution, PXC mechanism, hardware settings, blah, 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 etc. And you are going to create one equipment profile per hardware, per each equipment of node. Okay, so you can this way manage multiple kind of hardware. So here I have one for my management node, storage, blah, 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 etc. Okay, so just you need to remember that an host can be in one equipment profile at a time only. A server cannot be an HP and Dell at the same time. It's Dell or HP, okay? So you need to be sure you are in just one equipment profile, in only one group of equipment profile. For you to know the equipment profile variable are prefixed with EP. Same for authentication, they are linked to the equipment profile. And you cannot, and this is mandatory, be careful, you cannot precedence the EP variable above group vars. You cannot set them at the host var level or at the kernel, at the command line level, etc. It's because, well, we had to, well, it was a big discussion at the creation of the stack, but we had to choose between simplicity and flexibility, okay? And basically, if you want to be able to bring support for all the hosts, for host vars, you will lose the group generic features. It will be a big loss. So we are using a small tip here. We are using host var groups, item 0. So because you cannot get all the variable of a group, it's impossible. But you can ask Ansible to provide you the variable of one host. So basically here what we do is we ask the variable of the first host of a group, okay, to grab the equipment profile variable for some roles. But because we do that, if you precedence IP underscore variable above group vars, you will not know how the stack will work after that. You will lose, you will not be 100% sure how it will work. So you have to be careful. So it's kind of limitation, okay? Any question until right now, or can I continue? No, everything is okay. Okay, so let's proceed.
Yeah, you can continue.
Okay. So the important roles available. So the concept is you have a lot of roles provided by default. You can create your own one. And basically, if you match the inventory structure, there is a data model provided. You can, it's kind of a puzzle, you know, you just bring whatever you want and you deploy the final host, okay? So you are doing your shopping between all your roles, all the one provided by the community, your own one, and you deploy your final system. So as I said, the stack is split between core and community. The core part is dedicated to deploy bare metal system. Okay, so how to deploy very basic service that will be generic for anything. Deploy operating system, of course, set up the DNS, host file, time synchronization, all of these repositories, everything, I would say low level, okay? And then the community part is dedicated to provide advanced and dedicated feature over the core. I want it to be an HPC cluster, so I bring the Slurm community role. I want to do monitoring on it, so I bring the Prometheus community role, etc., etc. So it's kind of specializing. The core is generic. It's not HPC only. You can deploy enterprise network. You can deploy university workstation, laptop, whatever you want. The community is here to specialize thing. Okay. So available roles. So as I said, you have a lot of them. Maybe you want to know that there is also a diskless one. So if you want to deploy diskless operating system, it's also possible at the cost of a bigger RAM footprint of the operating system, of course, because everything is in memory. You don't need the hard drive anymore. But diskless is interesting if you're somewhere with earthquake, for example. Well, not anymore with SSD, but Diskless is interesting. Okay, it's kind of interesting in many way. It's cheaper. It's more reliable because when you reboot, you have a fresh operating system. So it can be interesting, especially if you have frequent power cut. For example, I worked in the south of France.
Hello.
Hello,
Ah,
can I just finish my sentence? Then I answer you.
for example, the thing client for remote desktop like the thing client. Can I
Hmm?
use the diskless or not?
Computing.
Yeah.
Yes, yes, you can, but you have to know that the diskless use, well, it will put the whole operating system into memory. So you need at least 2 or 4 GB memory to store the operating system.
Oh, yeah.
You see what I mean? So if your thin client have, I would say, 4 GB memory, it's okay. If you have 2 GB memory, it's going to be a bit difficult because you will miss memory. See what I mean? Um, well, on
Thank
the
you.
other part, well, it depends. You have two ways of doing diskless.
Mm.
The stack provides two ways. You
Yeah.
can do live net diskless, so you put everything in memory. So yes, here you need memory. And the other way is NFS diskless. You can use that also for thin client. Maybe it's a better way. It means that the operating system is stored on a server
On the server.
and you just mount it locally and start it. So it reduces a lot the memory, the use. But
Mm.
on the other hand, you need a better network, it because it's going to use the network to write and read.
Yeah.
So you need, well, it's okay. It's work. It's fluent, but you just need to be sure that you have a correct network.
Yeah. Thank you. Thank you.
You're welcome.
Yeah.
That's a very smart idea. Yes, same client are a very good target for NFS diskless, for example. So you don't need to have storage locally. And well, as I said, you have more also advanced features, blah blah blah. There is also a clone rule. The clone rule is interesting because maybe you want to be sure you have a backup of your management node or a very specific host. So the clone allows you to PXE a server that is already deployed, and it will bootstrap something called Clonezilla. It's an open source tool. Clonezilla will backup the current hard drive of the host, and you will have an image. And later, you can, through PXE, redeploy the same image on the hardware. Okay, so it can be a way to back up your management node, for example. Maybe you want to do that. So let's focus on the two most, I will say, important role for you, PXE and diskless. So the PXE, you have seen that it's, well, in my own experience, it is the most stressful moment when you deploy because you will face all the possible issues. Since you are discovering the hardware, you will face the hardware issue. Maybe you have hosts that are broken. Maybe you have hosts that don't want to boot. Maybe you have failed hard drive, memory issues, whatever. This is when you discover that because you are deploying the operating system the first time. You have to face the network issues because you are using the network also for the first time when you deploy an HPC cluster. You have to face security issues because, well, your cluster is vulnerable at this moment. Okay, you have no security features enabled, so you have to be careful. You have to face bad configuration, etc., etc. So the PXE is the most difficult moment of a deployment. Once you have deployed your operating system on the remote target, things are, I would say, smoother. Okay, so it has to be very simple and verbose. Okay, we try to make something that rely on text file only. And well, since you already worked with IPXE on the IPXE chain mechanism, it should be simple for you. Okay, so let's focus on two nodes. Again, my management and my login node. And let's see what's going on during the Bluebankis PXE part. It's very similar to what you did, but a little more sophisticated because now we need to handle more features, and also the fact that sometime, many time, your remote hosts are going to boot over PXC each time by default. So if you do what we did the first day, you will end up in an infinite deployment loop because the host boot in PXC, start IPXC, deploy, but reboot and redo the same and deploy, and it's always like that. So Bluebank brings a way to prevent that, etc., etc. So it's a bit more sophisticated. So how it works? Basically, we have our management node or compute node. So we can imagine the compute where it should be login. Sorry, I made a mistake. It should be login here, but it's the same thing. We don't care. So basically, your management node is deployed. This one is not deployed. So Ansible on the management node is going to deploy your DHCP configuration. It will deploy your TFTP server with your IPXC ROM created. And it will deploy the HTTP server with all the file needed, prepare the repositories, etc., etc. So you have everything prepared to deploy your target. Then at the boot, the target is going to ask, hey, I am this MAC address. I want an IP. So the DHCP server will say, okay, take this IP. And also for you to know, your next server is 10.10.01. So it's me, in fact. And the file name you need to use is ipxcrom.ufi from TFTP server. So right now, my compute node knows his IP. Okay, we have stored an IP in memory. Okay, so now 10.10.01, because DHCP provided me that, I want ipxrom.ufi. It was provided by the DHCP, remember. So okay, here is your file. Okay, so it's the ipxc file we created, remember. So now on my compute node, I have my IPXC ROM starting and loaded. Okay. So as you have seen, the IPXC ROM, when it starts, when it's booting on the remote target, it's going to ask again for the DHCP parameter. We need to refresh everything. So dear DHCP, can you remind me who I am, in fact, because I don't remember. So sure, you are compute one, your IP is this one. Okay, so I also know my host name now because I did the IPXC ROM by requesting again the information, knows the host name. Okay, so now I need to grab file because this is hard-coded. It's like the convergence.ipxc file. Remember, we created a boot.ipxc file the first day. It's exactly the same. It's just another name, but it's embedded inside the IPXC. So it's hard-coded. So I want convergence.ipxc file, and then from this file, I know I want my node compute, so my hostname file. It's exactly what we did the first day. Okay, so here are your files. So I have stored my two files here. So by default, in my host, my compute1.ipxc file, I have multiple parameters. These one were generated by Ansible again on my management node. I know what is my target, what I should do. Do I need to boot to deploy operating system? Do I need to boot on disk? Maybe I'm not here to deploy operating system. I just need to boot on my disk. Okay, so this is here where the node knows what to do. I also know here what is my equipment profile that was defined in Ansible. So all these data are now known by the remote target, okay, which has no operating system right now, just the IPXC ROM. I know my kernel parameters, maybe other things there, and then I want to change to equipment profile on the name of my equipment profile defined here. So right now we set a variable, set equipment profile type C, it's a variable set, and we reuse it dynamically here. So I'm going to grab my equipment profile parameters, okay? So all of this is stored in memory. So, hey, please, now I want my equipment profile parameters. Please, be nice. Okay, here is your file. So in this file, I have all I put in the Ansible inventory again. You have the hardware stuff, so the console, kernel parameters, the distribution to use, CentOS, which version, etc., etc. Then IPXC dynamically compute few things. So we create the dynamic route, the image route, the repository route, the kickstart path from all the variables we have gathered until now. Okay, so we create all of this. And then we change to a menu because IPXE allows to create menu. Okay, so I have stored all of my boot parameters here. And now I want the menu. By default, I ask for the menu. Okay, so here is your file. So basically, it's a very simple menu, like with red and blue color. And what is interesting is, and this is where we have the switch. Okay, it's like a train. You choose your destination. So you have the switch here. Remember, we grabbed at the very beginning what we called menu default. So if I come back, in this file, we add the menu default. Here it's boot operating system deploy, for example. It was in memory. And now with the menu, this small variable is used to set the default entry of the menu. So if I am on boot OS deploy, I will be on deploy operating system. But if I was in boot disk, by default, I will be on boot on disk. And after 10 seconds, if you don't do anything, the node will start the entry. It will trigger the entry. So if I am in boot operating system, boot OS deploy, so basically in the menu, I will be here. And at the next, after 10 seconds, it will deploy the operating system. Okay. So if we are deploying the operating system, then basically, then it will ask for the kernel, the initramfs. They will be provided through HTTP by this management server. Well, all of this, you already did that. It's the kernel line with everything, etc., etc. So we store the kernel, the boot, the initramfs, etc. And the node is booting to deploy. Okay, so we boot. Basically, it starts to boot. The node asks for the kickstart file. Again, we did that the first day, remember? So the kickstart file is provided. The kickstart file was generated by Ansible. We store it in memory. And then the kickstart is used to deploy the operating system. So we are grabbing a lot of packages and we install the operating system. Once installed, the node will inform the management node it has finished to deploy. And this is one of the important parts. Now, it's not what we did the first day because it was too much sophisticated for the first day, but right now with the stack, the node will say, hey, look, I have finished to deploy. That's done, finished. So next time I can boot on disk. And the management node will say, okay, next time you will boot on disk, and it will update the file locally on the management node. So at the next boot, the menu default we have seen is set to boot on disk. So at the next boot, the menu default will be set on boot disk, so the node will boot on the disk directly. Okay? Because sometimes you have nodes that always boot over PXE. So that's a way to manipulate them. Well, so if you want to follow the deployment, for example, you can use this command. Okay, so you can use journalctl to watch the DHCP and the ATFTP log. Right now, the stack is still using the ATFTP daemon to provide TFTP. And in the next version, it's going to use the Facebook TFTP you have seen the first day. We are migrating also on the Facebook TFTP. So I provided in the first practical session what we are going to do in the next version, in fact. Okay. So I think right now, just give me a second. Yeah, okay. So now we have finished with this. I'm going to do a demo for you to see what's going on. Okay? Okay for everyone? So let's deploy this cluster. Okay. So I will deploy my management node. Okay. So this is basically my all the things I need. So I will just, well, because this is an example, I will comment a few of them to speed up things. I want to have things very fast. So SSH, DHCP, DNS, yes, DNS client. No, don't need this one. See, I don't need this one also either. Okay, I want things very fast. So I will just add this one to be sure it deploys the first time. And let's Ansible playbook management. Yes. Yes. I just need to disable the firewall because I stopped it. It's in inventory because, for example, here I set in my equipment profile that I want the firewall to be enabled. It's disabled on my system, so I need to disable it. M. The firewall is false. Oh, I forgot to grab this package. No, it should be okay. Why don't have? Huh, strange. Did I miss something? Oh, I forgot to mount the ISO, I think. Yeah, I forgot to mount my ISO, okay. Because I rebooted my VM, in fact. Okay, so you can see that the whole configuration is generated, the DHCP, the host file, the DNS, the PXE stuff, everything is generated in one time. This is the first time I deploy this VM, okay? It's a fresh new one, and it's going to be configured. So let's wait for it to finish. Right now it has finished. So you can see now I have a DHCP configuration. I have an host file. The host file was generated with all my host, so one of my inventory. Okay. I have my DHCP. This network. So I have all my hosts in my inventory. Everything that was described in my inventory here. For example, my compute nodes are here. All my compute nodes are here, etc. Everything that was described in the inventory has been deployed on my management node. So I have now a management node ready to deploy the other node. Okay, that's all. So right now you have a small tool called bootset. We'll see that in the documentation that can manipulate the PXE deployment. So now I say I want to deploy C001. I put one more. Yeah. I want to deploy a C001 node. Okay, so this node, this one is inside the inventory. I want to deploy this one now. Okay, so you say, okay, bootset, so this is the tool to manipulate, and it has generated, remember, the file we spoke about with the menu default variable, boot OS deploy, the equipment profile, etc., etc. Okay, so it was generated in node C001. So let's boot the node. I just need to make sure that my MAC address match. So for example, this is C001. I need this MAC address. So let's modify my MAC address just to be sure we have the same one. Where is it? Here. HPC 00. Okay. 0D. Okay, so you have the same MAC address than here, and make it boot. So it's booting over DHCP. This is, well, it's a Terminator, okay? If you have seen the movie with Arnold Schwarzenegger, it's a Terminator. Anyway, and then it is starting, it's doing exactly what we have seen, remember the first day, so it's chaining to grab file, etc. And then you can see this menu. And after 10 seconds, it will boot the deploy operating system. So let's see what happened. It's exactly what we did the first day, okay? So let's check first the DHCP, the TFTP. So it's, remember, we are using ATFTP instead of Facebook TFTP, but I will drop ATFTP in the next release. Now we are going to move also on Facebook TFTP. So right now, again, I will reset it. So you can see we have the first DHCP request right now. Okay, look, I want an IP. Okay, here is your IP. Now it's going to download the IPXE, and again, it's asking for an IP. Okay. So let's have a look now on the HTTP part. I am again resetting the VM. So look, have a close look. It's interesting. You will see that the node is going to request a lot of files. So again, we have the IPXE ROM with the terminator, okay, booting, blah, blah, blah. And then you will see the chain. Okay, so first one is convergence, then the node file, okay, node C0, then the equipment profile, then the menu. Up, so we have the menu now. Okay, and by default, it was on deploy OS, and after 10 seconds, it was going to deploy the operating system. So let it deploy the operating system. You can see it's grabbing the kernel on the initramfs. Oh, I think I made a mistake. I need to kill it, sorry. I need to kill it because I have a console set and my VM don't have any console. For example, I made a mistake here. I know that my equipment type C, so it's a compute. I call them equipment type C. You can call them equipment compute GPU if you want. Whatever. You just need to use equipment something. But I know that I put a console here. This is a console, for example, of my BMC. But since I am in a VM, I don't have a console. I made a mistake. It's simple. I just re-execute the Ansible playbook of my management. I just reapply configuration. Okay, just wait for it to reapply. So it's pretty fast, in fact, not that slow. And I am on a very on a not very powerful computer. So on an HPC computer, it's pretty fast. And now I can boot my node because if I check, it was updated. If I check the parameters of my type C, now I don't have any more console. Okay, so it was updated by Ansible. So let's boot again the VM, and it will deploy this time. So right now I could wait the 10 seconds, but I don't want to lose too much time, so let's force it. And the kernel is booting. Okay, so let's wait for it to start deployment. At this part, you can see it's downloading the basic image on the Kickstart. You see here, we have downloaded the Kickstart file. And right now, the operating system is going to deploy automatically. And you will see it's going to grab all the packages. So let's wait for it to finish. And right now, should be fast. Configuring storage, it will create the format the partition and then download all the packages. So right now it's downloading the packages. You can see that. And it will install the operating system. Okay, so basically this is how we deploy everything. So right now it has finished to grab the repository. So let's clear that here and let's wait for it to finish. You will see that. So remember, if we take a look at the node file, so it's C001, we are currently with boot OS deploy because we ask for an operating system deployment and it's still deploying. So let's watch what's going on after it deploy. It's pretty slow. What's going on my system? Do we have enough? Yeah, still have enough memory. So well, we have to wait for it to deploy. Are there any questions in the meantime? No question? Because I need to wait for the node to finish. So we have to wait like 2-3 minutes.
Are there questions?
No? Okay.
None.
Okay, so let's wait for it to finish. One thing you must know, by the way, let's take this moment. If you want to play with VM, when you deploy an operating system like Ubuntu or CentOS over PXE, you need to be sure you have at least 2 GB memory available on the target system. If you have lower than 1 GB, the kernel is going to panic because you will miss memory. Okay, so right now, for example, with my VM, I put 2 GB memory of RAM available. But once the operating system is deployed, I can reduce to 200. It's okay, 200 megabytes. I don't care. Okay.
Hello, can you do a summary of PXE for the deployment of PXE? Yeah.
Yeah. You want me to recap what's going on to summarize?
Yes, please.
Okay. Give me just a few seconds that this part finish and I do a full explanation again. Okay.
Yeah. Thank you. Thank you.
You're welcome. It's okay. It's one of the most important parts. So yeah, you need to understand everything. It's okay. So let's wait a bit. See, right now, that's the end. So the installation has finished. The system is rebooting. And you can see that just before ending, we can see a specific access on the management node here. It's a CGI access, to be exact. That's the node, the remote node that informed the management node that it has finished to deploy. So now, if we take a look at the file, remember, you can see it has switched to boot disk. So it means that right now, so let me kill it, I need to restart it. So right now that the node has been deployed, if I boot it again over PXE, let it boot, you can see that it's boot disk. So right now, since it has deployed, it will boot by default on the disk. See, boot on the disk. So it will just start your operating system the standard way. So Red Hat is going to boot the standard way. So this is not a deployment right now. We are booting from the disk. So the node will be ready after that. So regarding PXE, let me compute how I can. Well, I think the best way is to come back to the first day. So give me a few seconds. Where was it? PXE part, blah blah blah. Yes, here. You see my screen? Yeah, should be okay. Yes. So remember, we have a management node, and we want to be able to deploy the other node, okay, using PXE. So on the management node, you need an HTTP server that provides a package on kernel, on init from FS. You need a DHCP server that will provide IP, but also file name to be used with PXE. So all the PXE process, all the data needed. You need the PXE stack. The PXE stack is composed of DHCP server, TFTP server, and HTTP. In fact, it's the combination of these three services that make the PXE possible for the remote target. And well, you need to set in the DHCP what will be the file that will be downloaded by the remote target during PXE process, and that will be executed. So once a node boot, okay, you can see that if I boot my VM again, this one, you can see that when it boots, it's starting a PXE process and it is asking for an IP to the DHCP, okay? So basically, the DHCP will provide an IP, but will also tell the node, okay, you boot, you can use this file to boot. You can download this file and execute it as a boot source, okay? And that's basically what's going on. And the next server here is also a parameter to say what is the IP of the TFTP server to be used to download this file. So basically, that's what's going on. Let's move to this part. We have our node. Okay, so this is my management node with all my services running, TFTP, GHTTP, HTTP.
Yeah.
And my node is booting, asking for an IP. So it gets the IP from the management node, okay? And then the management node will provide the IPXE file that is executed by the remote target. And once the IPXE is executing, then you have control over the remote target. You have some kind of very small operating system. IPXE can be seen as a very, very small operating system. And then you can script whatever you want, and you can initiate the Linux deployment. Does it answer your question?
Yeah. Thank you.
You're welcome.
It did.
So I will let the node boot. I will change and force it to boot over the disk so we don't have to wait. Okay, let it finish to boot. Okay, so it has booted. So right now I can SSH on C001. Okay, so it's not going to work because I forgot to update my inventory with my SSH key. So let's deploy it manually. This is a mistake on my side. Yes, yes, I know, blah, blah, blah. Okay, so now I can SSH on the node directly. Okay, so I can push configuration. If I go in etc Bluebank keys playbook, I have my compute playbook. So I'm going to configure, well, let's don't use that today. I'm going to configure all of this. Okay. So hostname, repositories, host file, blah, 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 whatever. So just let me remove because it should be okay. So Ansible playbook, compute. So right now you can see that it was able to connect to C001 because I am targeting all the compute node, but it failed to reach the others because I have already deployed only one. So it deployed the configuration on the target, but you can see that it failed to do that on the other one because I don't have them up. I only have one VM. So if I SSH now on C001, you can see that I have my etc host file ready. It was generated. I can install package. Okay. Because the repositories were set up by Bluebank keys, the DNS is also set. Okay, so I can reach the DNS that was generated on the management node, blah, 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 etc., etc. So you can see that if you use a stack, you just have to fill the inventory one time, and then you can deploy all the nodes this way. So it's much faster, much simpler, basically. Okay. Okay, so let's continue. Where I was, blah blah blah. This. We have done that. Okay. So it was the demo 4. So let's move on to diskless now. Okay. So basically, diskless is a way to have remote target without disk. Okay. If I have an host with no disk, I want to be able to start it and have an operating system on it. So most of the time it's for compute node. When you have thousands of compute node, having a disk for each compute node has a cost because you have to buy them, you have to replace them when they fail. And also, what is interesting with diskless is that each time you reboot your operating system, you have a fresh new one. So if there is some kind of failure, you don't see it after a reboot. You have a fresh system ready, okay? But you have to pay the cost for diskless. You need a stronger network because you need to deploy everything each time. And most of the time it has an impact on the memory usage on the remote target, okay? So for example, here, you can see that I am using just let's say 100 megabyte memory with an operating system deployed on the disk, okay? And you will see that with diskless, it's much more. So basically how the diskless is working, you're going to generate a generic LiveNet image. Okay, we are going to see the LiveNet today. You can use NFS also, but I'm going to show you the LiveNet. So there is a tool in the Bluebank stack that is going to provide all you need. So we need to generate an init ramfs able to diskless, okay? And we are going to generate an image. We can then unmount the image, tune it to your need. You can deploy roles inside if you want using chroot. Okay, so maybe you want to deploy the host file configuration. Maybe you want to set up NVIDIA driver for GPU, whatever. Okay, then you just repack it. So you just deploy everything. You just then repack it. Okay, you repack the image to have a final image ready to deploy. And you are going to use the same tool, the small tool boot set, to say, okay, no, I don't want to deploy operating system. I want to boot an image. And you are going to boot your node with this image. So a few tips for advanced users. You should not really care about the size at the first time. You have to investigate the software you want to deploy. So my suggestion is you first create an image. You try to install with a very big space, okay? You try to install everything you need, but just what you need, okay? Don't, because we are using RAM memory here, so don't install too much things. Just what you need, and then just before unpacking, reduce the size of the image to exactly what you need. Okay, just keep 100 megabyte space for your virtual disk, and that's all. Okay. So let me show you how it works. So we are going to kill the node C001. And to show you I'm not cheating, I'm going to unplug the storage here, okay? So no more disk in my VM. So it's pure diskless. If I boot it right now over the disk, you can see that no hard disk found, okay? So pure diskless, not cheating, So, okay, so now I need to say I want the diskless to be enabled. So I will deploy the, let's use this one, the diskless role. So I can use tag to say, hey, I just want to focus on the diskless. Don't care about anything else, okay? So it's going to deploy the diskless PXE stack. So it's done. So let's start using the diskless. So I want to create a new image, but first I need to check if I have the kernel available. So right now, if you check, you have no kernel available. So let's get the kernel we are using right now. So everything is in the documentation, okay? So you just have to read it, but I need to show you how it works. It's in pre-boot, diskless, and kernels. Okay, so I just copy the current kernel, and I'm going to generate an init ramfs for this kernel, basically. So what we are going to do right now is we have a kernel, the Linux kernel of our operating system, but we cannot use the init ramfs provided by CentOS or Red Hat because we need additional modules to do the diskless. So we are rebuilding a new one with additional modules, simply. Okay, it's pretty fast. Okay, so it's done. So now if I list my kernel, I have this one available with an init ramfs ready. So let's create the image. So I want to create a LiveNet image. Okay, so just the part 2. So let's create a new, the name will be workshop. Okay, I'm going to use this kernel. The very secure password will be root. Okay, don't use that. It's just for the training here. I want to install a small one. Okay, the image will be 1 gigabyte size. Size out of limit. Oh yes, 1 gigabyte. Just too much. So let's create it again. Demo, generate, workshop, yes, root, 2 and 1 gigabyte. I don't want an SHP. I don't want to activate SC Linux. No. I don't need a release version. Maybe I need one. No, I don't need one. No. Okay, so I want to install that. So yes. Oh, I forgot. See, I need to remove. I made a mistake. I need to ask the guy to change that. Anyway, put to 1 gigabyte. No, 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 and no. Okay, so it's basically installing an operating system inside an image. Okay, so you can see that it's doing like exactly what we have seen in the Kickstart, but inside an image, a local image. So let's wait for it to finish. Okay. So it's still working. It has completed. So right now it's going to pack the image. Okay, it will compress everything. Because the image is compressed before being sent over the network. You don't want to send a 1 gigabyte image over the network. It's going to use too much network bandwidth. So the image is compressed, okay? And it's done. So if I now list my available image, you can see that I have the image workshop ready. So let's boot it. I will say again boot set, and I want to boot this class on image workshop. If we take a look now at the file, okay, say okay, you have to boot on this class and you have to use image workshop. So let's boot it again. Let's boot our node. I hope I have enough memory, but I think it's okay. And let's check what's going on with the HTTP server. So basically, at the very beginning, it's exactly the same as before. We have the ROM with the terminator booting, all the PXE chain, but at the menu, you will have a different entry selected. You see, now it is starting this class operating system. So let it boot. So basically, it has grabbed the kernel, and you will see during the boot that it's going to download the image. Right now, see, we have downloaded the Squash FS image, and the node is ready. So let's SSH on it. And right now, you can see that I am on a node that has no disk. Everything is in live RAM, live read-write memory. So if I do a free -h, my kernel is using a very small space, okay, but I am using also for my storage this this in my memory. All the operating system here is using my memory. So right now we have only this. I mean, from the 2 gigabytes that were available, we have only 1.4 gigabyte now available because the other part is taken by the live operating system. So right now we have a node with no disk. It just booted with no disk. Okay, so that's what is basically the diskless. So it's an interesting technology, quite simple. So if you need it, you can investigate it. Okay, it's up to you. No question regarding the diskless part?
Question? Are there questions? No question.
Okay.
Online? Can we ask the people online? You've not been asking question. So please ask question. Online?
The chat is here. What about the services that need to be? You mean the services on the target node, on the compute node, or on the management node? So on the compute node, in fact, this operating system will boot services like anything else. You just have to, if you want to boot a specific service, let's say I want to have the HTTP server on my compute node. Okay, let's say that. So I will ask for it. Do we have enough space to do that? Yeah, okay. So let's say I want to have an HTTP, it's completely insane, but let's say I want to boot my compute node and have an HTTP server booting, starting at the boot on my node. I can use diskless, okay, again, the same. I want to manage LiveNet. You have to ask for mounting an image. So I want to mount image workshop. So it will uncompress the image, mount it. So let's exit it. It was mounted in blah, blah, blah. Where is it? Here. Okay. So if we have a look here, T, I have my image. So I can ch root just here. And I can install my, so let's do it, for example. Okay, I want to install things. So I'm going to cp my whole, because in normal time, I'm using Ansible to do that. But to speed up things here, I will do it manually. Okay, so let's go in my chroot. So let's copy our current repositories here, inside here. Okay, and now I'm going to chroot into my image. Okay, and I can install HTTP. Oh yes, because it was still the old way. We have to update it. Forgot. Well, to speed up things, I used a bit things, and I forgot some few things. Okay. I did things too fast. So let me show you so you understand. Okay. This time it should be better because I made the first one manually, so it was broken. So I am in the image, okay, right now. I asked to install HTTP, the server. I enable it. So it will create a symbolic link. I cannot start it because I am in a chroot of my image, okay? So I exit my chroot. So right now, let's also create something so you can see it. I will say echo hello and put it here inside my image. hello.txt. Okay, so right now in my image, I have also a file called hello.txt. So I will pack my image right now. So unmount image, so image workshop. So it's going to repack the image. Now I have finished. I just installed the service I want. So now I am going to repack the image. So in normal time, I'm using Ansible to deploy the configuration inside my CH root. Okay, but right now to speed up things, I did it manually. So let's wait for it finished. So now let's boot again this node. It will act as if I have installed the HTTP server inside directly. So let's wait for the node to boot. Okay, so it has booted. So let's SSH on it. Of course, it is refused because we don't know this host. Yes. And if you take a look, we have the HTTP server running on the compute node, on the remote target. Okay, so you can do it basically with everything. You just can't activate services inside the CH root, but you can enable them so that at the boot they start when the image is booting. Does it answer your question? Okay, cool. You're welcome. No more question?
Any other question? Online, if you want to speak, if you feel speaking will be more comfortable to you than typing, you can enable your mic to ask your question, please. Okay, no question.
So either it was not clear or it was too clear. So we will see. It's 11 here. I need to leave for now. We will continue this afternoon. Okay. Well, let's just finish with the conclusion for Bluebank keys. On this afternoon, we will see the monitoring. Okay.
Okay.
So conclusion for Bluebank keys. So as I said, Bluebank keys is generic stack. It's not limited to HPC. You can use it for many things. It can cover a lot of projects. So as I said, IT infrastructure, storage, workstation, etc. For example, in Atos, it is also used to manage storage for a few things. We plan to use it to be used also for some cloud stuff. So it can be used for many things, in fact, okay? Because again, it's just a core to deploy target, to deploy bare metal servers. And then you can use communities roles to specialize if you want, but the core itself is completely generic. So it was made to deploy operating system. And also it can be deployed in containers, VM, cloud, whatever. So quite easy to be used. So I made this training the way that you understand how to do it manually, then how you use Ansible, and then merge both of them to create a stack, a unified stack, so Bluebank keys. Again, it is just an example. You can use Bluebank keys if you like it. You can create your own stack if you want. You can fork Bluebank keys if you want. You can use whatever you want. It's up to you. It was just an example of what you can use. And if you want to use Bluebank keys, you have to know that the stack is pretty young, so maybe some roles, tools are missing. Don't hesitate to ask or help if you want, okay? So this is a practical session for this afternoon for you, and we are going also to see monitoring this afternoon, okay, Prometheus usage, because I think that this, I would say it's the last part to see as an HPC cluster deployment. Once your cluster is ready, you need monitoring to ensure everything is okay in production time, to be sure you don't have any hardware issues or stuff like this, okay? So we will see that this afternoon. If you don't have any more questions, I think we can stop here for this morning. Take the time to, well, have a fresh air, digest and have a fresh air. I know it's a lot of things.
Okay.
Thank you very much for attending, and let's meet at 1 p.m. for you and 2 p.m. for me.
Okay. Thank you very much.
You're welcome.
Yeah.
Bon appétit. Thank
Right.
you. Bye bye.
Bye bye.